Hello everyone, in this video I will be discussing a common responsibility of a cloud engineer or the DevOps. That's deploying applications and creating resource for them. My focus in this video will be starting from the domain to the pod in the Kubernetes. For the resources, I use Terraform, but I'll be deploying in the AWS. And for the Kubernetes, I'm going to create a YAML file and deploying and show you how it's working. If I want to talk about it in the higher level, that's starting from the DNS. And when we enter the domain, our request goes to the load balancer. Actually, it goes to our um, traffic goes to the load balancer, and here we can handle the firewall, handle the request by the firewall. That's a WAF in the AWS. Then the load balancer route our traffic to the target group. This target group is connected to the EC2 node in the Kubernetes. Then will be connected to the service, and the service connect to the pod. But let's go more deeper in this detail. For example, what is the load balancer? Here the main things that's once you need to create it for the old applications or based on the request for the company. Maybe you want to create a load balancer for the public application, one of them for the internal application, or one of them for the, for example, web team, one of them for the data team, one of them for the other teams. It's depend on your decision. But what is the load balancer? Here, that's explanation from the AWS. Actually, the Elastic Load Balancer is distributing the incoming application traffic and point to the other services. The other things here, it's firewall. If you want to block some request, for example, if you want to say that this IP can access to this target group, or this IP can goes through this pod, or if you want to explain that, for example, this host name can just allow to be the access to the other service. Let's see what's in the AWS, what to say about. Yeah, in the AWS, it said that it's a web application firewall that lets you to monitor the HTTP and HTTPS requests and forward them to the load balancer. So if we connect to the WAF to our load balancer, first it goes to the WAF and check if it's allowed to go to there and say that okay, it goes there. If we check the actions here, we can see that we can create an IP set. We can, for example, most of the important one, you can create a web ACL. You can say that, okay, these headers or this host name, this request can allow to do this stuff. The other one is the target group. Actually, a target group is route the request to one of the registered targets. For example, it can be EC2 in the EKS, or it can be to the other stuff. But let's see, start from the load balancer, because at the first you need to create a load balancer. Here is the code for the Terraform. That's you can see we're going to create an AWS load balancer. That's call it demo. For us, it's not internal, so it's false because it's a public application. It's an internet face application. It's I'm not going to explain all things in the load balancer. For example, we can create an application, or we can create other types of the things. But here, because it's our HTTP request of our application, it's a web page. It's point to the application. You can set a subnet, enable the attention protection, or you can create some security group. For example, this CDR can access to this load balancer. So first you need to create a load balancer. If we want to check in the AWS, after we create a load balancer, we can go to the EC2 load balancer, see the demo one. Here I created two listeners, one of the port 80, the other one is the port 443. That's redirect this stuff to the HTTPS. That's the whole thing that you need at the first for the deploy the application. You need the load balancer. Then I'm going to explain the rules here, and then I explain the more stuff here in the later. But after the load balancer, when someone requests to create an application, first you need to create a DNS. So when you enter the URL or point to the application that goes through the load balancer. If you want to create a route 53 for the DNS in the AWS, it's called route 53. You need to point to your zone ID. For example, for the test.com, if you have a zone ID, we need to point to that one. Then we need to, for my example, we have a demo.test.com. That's a type A for the route 53. Then we need to point this route 53 to the load balancer. After you created that point, you can see that if you go to the route 53 in the AWS, there is one record name that's called demo.test.com. Then in the value of the route, you can see here, it's point to your load balancer. That's demo, that's a region, EUS-1, and the ELB, Elastic Load Balancer, Amazon.com. So now our application is actually point to our load balancer. So for now, we created this resource. That's when we enter the URL demo.test.com, that's going to the load balancer. Here I'm not going to set any firewall here because it's you need to do more here. For example, you need to create a host, or you need to create an association between the WAF and the load balancer. Maybe in the next video or in the other video I'll be completely discuss about this firewall WAF here. But if you want to connect the load balancer to target group, we need to create a listener for the rule here that I talk about it here. For example, there is a rules here. So now it goes to the HTTP, for example, demo.test.com. Now it's redirected to the HTTPS. Now in the HTTPS we have 16 rules, for example. But one of these rules we can create by AWS load balancer rule for our demo. We need to connect our load balancer here with the AWS load balancer. Then in the action, we need to point to our target group. But what is the target group? Now I explained that the target group is actually connected to our EC2 in our EKS. I'm showing that how we can create that one. So here I said that with which condition that's forward to this target group. Now I say that okay, if the host demo.test.com point to this target group. Let's see, I create, okay, that's a rule that I created. For example, it said that okay, this header, if it's demo.test.com, that's forward to target group -demo. Let's say I create a target group. Yeah, that's how you can create a target group. Now I create a demo target group, demo-tgb with the port 80. That's connect to that load balancer. In the rule, actually we point to this target group AR. That we saw that here. So this is our target group. So if we go to the EC2 target group tgv-demo, we can see that our target group. Here we can see our registered EC2. Actually, after you created these resources, it's not we don't have any registered here. It's 0, 0, and everything here is 0. But after you create a target group binding, actually it's going to register to the target group. So after you create the resources, this section here should be empty. And here it's explained that, okay, that's the details, that's a target group. And here it said that, okay, this connects to the load balancer, that's called the demo load balancer. And this is everything that about the target group. After here, everything goes through the EKS. For example, here, it starts from the EKS. In this one, we explained that, okay, it's connected to the point 31,656. So here, we have a node in our EKS cluster that's connect this target group to this node. But let's see how we can connect these things together. In the further, I'll discuss more about it. But for we need to create our applications. Let's see. I'm going to connect to my Minikube here. If you can see, yes. Here I have a deployment and the service.yaml. First, let's see the deployment one. So I can bigger this one to see it better. Yeah. Okay. Here I created one deployment that's called demo and label that's app demo. I said that I want to replica that's with the match label. Match label is actually this connect this deployment to the pods. But how you created a label for the pod? That's here. That's a template for your pod. You say that, okay, set the label, that's demo. For this demo, I use HTTPD. That's just for the testing. That's Apache service. I set the version here. That's named demo. For this Apache, the container port is 80. I call this container port demo that I use it in the other deployment that I show you in the further. And the protocol is TCP. But first, let's go and deploy this deployment. kubectl apply. Now, first I create a demo namespace. Then we're going to deploy this deployment. So that, okay, it's created. Let's see in the get pod. Okay, it's running. Now we have two demo here. After that, we need, that's I explain it, that's deployment.yaml, but we need to create a service. For this service, we're going to connect our pods to the service. If we want to connect it by the port forwarding, the local, or we want to connect it with the target group binding, first we need to create a service. Let's see our service here and explain each parts. Here we call our service demo target group binding service. Here we say that, okay, that's name our port service, that's HTTP. This port is actually a port of the local part. It's not related to the AWS stuff. That's if you want to connect to the pod locally by the other pod or by the port forwarding, you need to connect with this port. But one thing that's called node port that should be unique, so you can't have another application another service with the same node port. Same node port should be the unique, because you need to connect it to the target group binding. If it's connected to the two different two pods, two services have the same node ports, so actually it's not working. Don't know which one should we show you here. Here, so first we create a port, node ports, and the target port. Target port, you can point to the, for example, 80, or based on the that I explain it, let's see it here, it needs to be these name ports, because we call our deployment port demo, so we can call it here demo2. That's actually name of your pod container ports. This selector first, you know that I told you, you can have 4 pods or 5 different pods, 5 different deployment with the same target port, that's demo, or call it 80. But how is this service going to find that it should be this port? That's by the selector. It's going to say find the pods with these labels and connect to this container port. Let's create that service. We can use, because it's a YAML, we can just apply it with the service. That's yeah, now we can have a service. Let's see the service. Okay, now we have a demo TGB service that's type node port with the IP, and it say that this port, actually the now we have 2 ports. The 8080 is the local one, and the other one is the node port here. This one is connected to the AWS, but what is that? How we can use that? If we want to connect by the another part, or if you want to test your application, for example here, we can do the port forwarding, as I have here. We can port forward in the namespace demo with this service that we have it here. We can connect our local part 8080. You can say that whatever you want. It shouldn't be the same as here, but this one here is actually this port. Let's run it. So now it's forward our ports. So the local port 8080 connect to the 8080 here. If we didn't set it correctly, like selector or the not connect this port, couldn't find the service, couldn't find the port or something like that, it's not showing that forwarding. But it seems that our connection now is working. It means that our service connected to the ports. But how we can test it? Let's see. Yeah, here that I used localhost 8080. Yeah, it said that it works. And we can see this connection here. So now we know that our deployment and our service is working, and we can connect it locally, but we need to connect it by the domain, for example demo dot whatever. So we need to register our node port here that I told you. If you created this one, this place is it should be empty at first. But how we can register this stuff here? So now we have this service here. All things here is working and is connected, and we created everything here, but we need to connect this connection here, and it's happened by target group binding. There's one resource that's called target group binding. You can create it by the YAML file target group binding, and you can create and register stuff here. For example, it said that for the ingress, you can set the just this IP can connect. That's connected like a security group working. And ports, we say that we want to register 31 656 54 ports, and this port actually that's a register port in the ABS should be connected to this service demo-tgb-svc. That's with the ports. But here you need to point your target group ARN. So when you create a target group, here you have ARN. You need to put this ARN here. After you point this target group here, these two connect to each other. So when you say that it's let's say back here. So now when you connect, when you say that demo.test.com, it goes to the load balancer. Actually, first check by the firewall. If it's okay, it goes to the load balancer. It goes to the target group binding. Now it's connected to our node port in the EKS. So it goes and connect to this target group binding. And this target group binding, if you check it, it's locally, it's working. So now everything should be work because it's connected to the service, and the other is like a port forwarding that we did. But the one more thing, that's a target group binding, is not something in the Kubernetes. So let me show you. I can see that here. That's let's see, target group binding. Yes, that's AWS load balancer controller. I can find. Yeah, here is better. This target group binding, before that you need to install the CRDs for the AWS load balancer controller. If you created this one, then actually it's gonna understand that okay, when it's mentioned that this target group ARN goes to and register this EC2 node to the target group binding. So in this video, that's the whole things that I plan to explain it. So now our application is work, and it starts from the DNS to the pod, and it's connected to the DSpot. Thank you for watching this video.